The intended audience for this tutorial about structured credentials is a broad range of professionals interested in furthering the application of verifiable credentials technology for use in software applications, agents, and services. The primary audience includes software architects, application developers, and user experience specialists, as well as other people involved in a broad range of standards efforts related to decentralized identity, verified credentials, and secure storage. The purpose of this tutorial is to create the following in the mind of each intended audience member. I think of this being a range or a spectrum of 4 levels. You can create awareness, knowledge, understanding, and or wisdom. Awareness being an overview of what is being described. Knowledge being just basic information about what is being described. Understanding is the how of what is being described. How can I use this? How can I apply it? Wisdom is deep knowledge and understanding acquired only through experience. For this particular tutorial, I'm focused on the needs of software architects, developers, and user experience specialists, and imparting knowledge and understanding, fairly deep knowledge and understanding of what a structured credential is and how you might use it. Based on some very good CCG community feedback, I've added this 3-slide section to provide an overview or a level of awareness of what structured credentials are all about. So the first slide is the structured credential model, and I refer to it as a 3-dimensional 2x2x2 diagram. Across the top we have anonymous credentials and named credentials. Along the side we have verifiable credentials and non-verifiable credentials. Non-verifiable credentials have no proof element, so they're just there, they're just data. Verifiable credentials have a valid proof, a validatable or verifiable proof. So that tends to be information we're more willing to trust depending on the issuer or the source of that. Across the top, an anonymous credential has no credential ID, no top-level ID on what I call the envelope. Named credentials have a credential ID. And then if we look inside the orange box here, named verifiable credentials, the intersection of the named credential and the verifiable credential regions, we have bound and unbound credentials. And what we're talking about there is whether that business data or that metadata, that inner credential has a credential subject ID. If it has a credential subject ID and the value of that ID is some sort of identifier that's associated with a subject, then we call that a bound credential. And if you follow through the rest of the presentation, you'll see examples of that. An unbound credential doesn't have a subject ID, credential subject ID, and so there's no inherent subject, it's just data. And if it's a named verifiable credential, it's data that has been signed by an issuer. It's just not associated with anything. So the primary colors examples are the best example of that. When we talk about structured credentials, there's this concept of the envelope. And the inner credential, the business data, the metadata about somebody, the driver's license, the health pass, the idea is it goes inside a credential envelope. And that credential envelope has an outer ID. The credential itself inside has an ID. We refer to that as the credential content. On the outside, we have a packing label, which is just kind of some I don't want to use the word miscellaneous, but some additional metadata that just doesn't belong anyplace else, so we put it on the packing label. And then what makes this a trusted or verifiable credential is the fact that it has a seal on the outside. Think of it as a wax seal from the days of old. So there's really four things, of which you see three of them here. The one that you can't see is the envelope content. It sits inside the credential envelope. On the outside of the envelope is a packing label, and that is secured or made verifiable, made trustful by the presence of an envelope seal. And so that concludes the overview. If you want to learn more, continue watching the presentation. And once we have that, all four of those elements together, we have an overview name for that called the verifiable data envelope. So the third slide is this bound credentials example. It's a bound credential because down in the credential subject it has an ID, and the value of that ID is an identifier associated with a subject. It doesn't have to be a DID. It could be any identifier according to the specification, but the fact that it has an ID means those claims, in this case the array of colors red, green, and blue, it means they're associated with a named subject. And really the purpose of this slide is to take those previous concepts of the verifiable data envelope and map them onto this JSON example. So here we see the credential envelope, i.e. the whole verifiable credential. Here we see the credential content, which is the context, and the credential subject. We have the claims, which is really that core business data or driver's license, name value pairs or claims. We also have the identifier, again, if it's a bound credential. We have the packing label, this additional metadata that's used to help describe the content and the format of the content. And then at the bottom we have the envelope seal. Of course, the envelope seal is on the outside of the credential envelope. It's separate from the credential envelope. Everything else is considered part of the credential envelope. The last thing I want to note here is at the very top there in line 2, there's an ID property. And that's an ID property for the credential envelope. And I go into a little more detail if you want to watch the rest of the presentation about the structure of structured credentials and the role that each of these elements play, and in particular the difference between the two kinds of IDs. Credential is. By the way, my name is Michael Herman. I live on a cattle ranch in Alberta, Canada, and that's it hosts the location of the Hyperonomy Digital Identity Lab. And you know, what could the possible relationship be between the two? Well, it turns out that if you're a cattle rancher, there's lots of relationships. Your cattle have an RFID tag in their ear. They have a brand on their side. There's linkages between cattle and the offspring, whether it be the mother cow or the bull. They generally belong to some sort of entity like a ranching company. The ranching company will have an address or a location, and that's what we call a legal description, Alberta legal description. And then that company may have other identifying information associated with it, such as box number 45 in Bindloss, Alberta. So it turns out that the place where I live, the cattle that I own, have a lot of relationships and are very amenable to a lot of this stuff we're talking about when it comes to verifiable credentials. Next, we're going to go into a series of slides that give you a deep understanding of a deep sense of knowledge and understanding of what a structured credential is. Remember, knowledge is the what? Basic information about structured credentials, and I also show some examples so that you can get an understanding, like how these would be used. And then we'll just go on from there. Welcome to this tutorial on structured credentials and the structured credential model. Here we can see a bit of a taxonomy that I think encapsulates all the different possible kinds of credentials. Across the top we have verifiable credentials, and those are credentials that have a valid proof element within the JSON of the credential object. And if we look at the two columns, we have anonymous credentials and we have named credentials. And the named credentials column in the blue here means that it has a top-level credential ID. Anonymous credential doesn't have a credential ID. Where I'm really focused in today's discussion is introducing this taxonomy just to this level of detail, and then talking specifically about named verifiable credentials, or NVCs. That's the brown box in the top right-hand corner. If you're familiar with the Verified Credential Data Model specification, it also talks about something called bearer credentials. Bearer credentials are an example of an NVC, unbound credential. An unbound credential is a credential that does not have a credential subject ID. Similar but different, there are NVC bound to subject credentials. They have a credential ID, and the credential ID has a value, who's an identity that is associated with some sort of subject. And we'll talk about those in a little more detail. There's an interesting definition of species, and I talk about these being different species of structured credentials. Feel free to pause the video and read that definition. So just sort of for the technical record, the difference between named verifiable credential, bound and unbound credentials is whether or not they have a credential subject ID, and whether that credential subject ID has a value, an identifier. If it does have an identifier on the left-hand side, we call those bound verifiable credentials. If they don't have a credential ID claim, and the value of that ID property is empty, then we refer to that as being an unbound credential. It's not bound to a subject. The other properties, such as the context, the credential ID, the verified credential type, all remain the same. Because we're talking about named verifiable credentials, all of these credentials also have a proof that's signed by the issuer. So here's an example, the famous primary colors example. This is a bound credential example. And by that I mean, within the credential subject, it has an ID property that has a value. It is bound to the value of the ID field, and that value, the DID color palettes 1, 2, 3, 4, is an identifier that's associated with some subject. The subject here happens to be a color palette, because we're using a subject that doesn't refer to a person or a traditional organization. In column classical verifiable credentials, that ID would be the ID of a person, let's say, and then the claims that appear below would in fact be metadata or extensions of that individual. When we're talking about inanimate objects or things, NFEs, the ID is actually the name of that object or that business document. We also have another ID up here. This is the ID for the envelope. This is the ID for that outer envelope that is wrapped around the credential and is used to transport the credential between agents. Here's an unbound credential. It has basically the same credential subject with the same claims, with a single claim here being an array of colors, red, green, and blue. And you notice that it has no ID. I deliberately left a blank line here to highlight that. Up at the top, the envelope still has an ID. So this is a bound envelope, a bound credential, or a named credential. I'm sorry, it's a named credential whose contents is an unbound credential. So leaving that discussion for a moment, we'll link back to it at the end. Let's look at what a structured credential is. And what we're talking about here is a metaphor, a model that is useful for explaining structured credentials, let's say to a software architect or software developer audience. It's actually a fairly powerful metaphor that I think a lot of less technical people would also identify with. So let's look at what a structure is. Okay, so as we talk about structured credentials, where do they come from? What was the impetus? What was the spark that led to their creation? Structured credentials have their roots in the verified credential specifications, but the real inspiration comes from the Trusted Digital Web project. It's available on GitHub. There's actually live code there. And there's a bit of a diagram, an architecture diagram, architecture reference model on the right-hand side. We're not going to go into that. But the idea behind the Trusted Digital Web is it's an end-to-end standards-based or standards-inspired, verifiable, fully decentralized object workflow platform. That's a mouthful. So if we break that down, it's not just a bunch of individual disconnected pieces of technology. It is an actual platform. And it operates end-to-end, right from the verifiable data registry to the concept of issuers and agents and wallets, the trusted digital assistant, key management, master key or master secret management. Those are all aspects of the platform. It's standards inspired, and what I mean by that is there's a specific standards roadmap based on DIDs and verifiable credentials and enterprise data vaults, but we're taking a very specific, a very deliberate approach to building the Trusted Digital Web platform. The first is we want to make it work. In a later version, we'll make it work better, and in a third version, we'll make it work right. And so in the beginning, when we're just trying to make it work, we're deliberately not being standards compliant, but we are being standards inspired. And what I mean by that is that we'll have all the information and data elements in the platform to support the specifications as they're written today, but maybe from a pure interoperability perspective, data might not be where you expect it to be, or different sorts of differences of that nature. But you need to understand that that's deliberate. The whole idea of make it work better and make it work right is to move to being fully standards compliant once the basic platform functions are in place. So the platform also represents an important application of verifiable credentials. Using the verifiable credentials as a strongly typed object model for business documents. And by business documents, I'm talking about purchase orders, invoices, waybills, delivery confirmations. So how do we represent those in that JSON format? How do we explain them easily to developers using this envelope model that I'm going to talk about next? How do we exchange them between agents? Between ABC Grocery and David's Cabbage Patch. If ABC Grocery wants to issue a purchase order to David's Cabbages, and David's Cabbages is going to ship those, issue a waybill, they'll receive a delivery confirmation that those cabbages that have been received by ABC Grocery, and then David's Cabbages, of course, wants to send an invoice and get paid. So it's the whole, what I call business orchestration scenario that we're trying to support. And the part that we're going to be talking about, structured credentials, fits in this rectangle within the architecture reference. Okay, so what is a structured credential? There's 4 elements to a structured credential: the credential envelope, the credential content, the packing label, and the envelope seal. 4 elements: the envelope, the content, the packing label, and the seal. So we start off with the credential envelope. Remember when we were talking about that JSON example, the primary colors example, there was that outer ID? Well, that's the ID for the credential envelope. That's the ID for that outer structure of JSON that in which the credential data, the business document or what have you, is embedded. We're going to see an actual JSON example later on where I'm going to color the different parts of the JSON to represent the envelope, the content, the packing list, and the label. So there's a little piece of paper in the envelope. That's the credential data. That's the credential subject claims. And so when you put those claims, the business data, inside the credential envelope, you can seal the envelope, attach a packing seal, and this is what you've got. So think about what we have so far. We've got data in the envelope. That data is going to have a credential subject ID if it's bound. It's not going to have a credential subject ID if it's unbound. It's enclosed in this envelope, and it's got a packing seal on the outside. So is this something you can trust? Is this something that's verifiable? No, it's not, because we haven't attached the seal. We need to attach the seal, aka the proof. We need to seal that envelope, and once we've sealed the envelope, then we have a verifiable credential, or what I like to call a verifiable data envelope. And when you think about verifiable credentials, you're not actually verifying the data itself in terms of its authenticity or truthfulness. What you're actually doing is you're verifying the envelope. You're verifying the container that's being used to transport that data. So just to highlight that, when we have a credential envelope with a seal, we call that a verifiable data envelope. Let's look at what this means in code. So within the Trusted Digital Web, we use an interesting technology called the Microsoft Trinity Graph Engine. And there's so many cool things about Trinity that it could take a couple hours to explain. I'm going to try and just come up with the highlights here, particularly how the data structuring works within the Trinity graph platform. So what you're seeing here is a snippet of the Trinity specification language. The Trinity specification language is used to describe data. That's one of its uses, through the use of structures. And then those structures can be used as what are called cells. And a cell is a slot where persistable data can be saved. And so you might have that color palette. You could say this color palette, in addition to being a structure of an array of color names, is also a cell. That means it's persistible in memory. It means it's persistible to the hard drive. The other cool thing about structures is they can be used to define request-response protocols. So the request, so you got protocol XYZ, you can say that the request, i.e. the outbound REST call, is going to use this structure, and on return, in the response, it's expecting this other structure. So I'm not going to show too much of that part where we're building protocols, but just know that it's there. The last thing that you can use the Trinity specification language for is to actually define servers. So you can say a server ABC supports Protocol A, Protocol B, and Protocol C. Now the cool part starts. You run this through the Trinity compiler. It creates an entire executable C# project that implements the server. If you declare your protocols to be HTTP based, they'll be public HTTP protocols. If you don't declare them to be HTTP, it's using an internal REST protocol. And so you've got just an outstanding capability here of being able to abstractly define your structures, abstractly define your protocols, and abstractly define executable servers that implement those protocols using those objects. Okay, so let's look at a specific example. So in the top green box, we've got a structure called postal address claims. And what we've implemented or designed this structure around is the schema.org postal address structure. If you look at that URL, you'll see that a postal address structure or postal address credential consists of a street address, a post office box number, an address locality, an address region, an address country, and a postal code. Those are the actual words and names out of the schema.org page for postal address. So we start by defining our claims, i.e. we start by starting to find that thing that we want to put in the envelope. What was the thing that we put in the envelope? It's called the content. So if we look down below into the second structure on the page, we can see the second green box, and there we have the claims element, or the claims property of the envelope content being defined. And what's it defined as? It's being defined as the structure we just talked about above. We can see that the envelope content also includes some sort of identifier called a UDID. It has a string of contexts, i.e. the @ context that you see in a JSON verifiable credential. And then you have our credential subject ID. Of course, that's marked optional because in an unbound credential, as we saw above, you don't need to include that ID. If you're creating a bound credential, then it needs to be there. So we've just described the envelope content. The envelope content, in turn, is part of the envelope. It's this thing that we stuff inside the envelope. So we're declaring an element called content, and its data type, its structure, its organization is that of the envelope content for the postal code. And that defines our envelope. So far we've got the claims that are used to create, or that are embedded inside the envelope content, and we've taken the envelope content and from a data structuring perspective placed it in the envelope. Now we're going to go to that thing called a cell. Again, cell is kind of a legacy term. It's a Trinity graph database legacy term. A cell, again, think of it as just a storage location, like a pigeonhole or a mailbox that holds a single entity. And in this case, we're defining what a postal address cell looks like. So what does a postal address cell look like? It's an envelope. It's an envelope, and it's a envelope seal. The brown box that showed up there, that's just highlighting that to finish off our envelope, we need to have a label that we attach once we've inserted the content into the envelope. So those give us the top level structures for defining a postal code and for using it on the trusted digital web, represented as a structured credential. Okay, so here's just drilling down into a couple things that we showed there at the end. So the packing label in a traditional named verifiable credential would just have the credential type, and you see that element there. The Trusted Digital Web supports different trust levels when it comes to sealing the envelope for protecting the content. So traditionally, verifiable credentials only have one level in the formal spec, which is verifiable. And so we start by saying You can just have a hash, a digital hash of the envelope content. If you want something that's a little bit stronger, you can have a digital signature of the digital hash. And if you want something stronger, then you can take that digital signature and create from it a proof using the issuer's public-private key pair. So that's what that trust level flag is. We also can provide encrypted claims as well. So instead of having them plain text in the verifiable credential, there was a field there that I kind of skipped over on the previous slide. You can go back and look at it. But the encryption flag is set in the packing label, and that causes the claims within the verifiable credential to be replaced with an encrypted blob. So here we are. We're going to come back and look at the claims and look how we program against those claims. So here's a piece of C# code. All of these classes, everything that's in that kind of magenta color is all machine generated. You press a button, that TSL is read by the TSL compiler, by the Trinity compiler, and you get a substantial C# project running in Visual Studio, and you simply code against it. So this is the only, aside from the abstract declarations that we made on those previous slides in TSL, this is the only longhand code, the only handcrafted code in the project. Everything that this is using is automatically generated. So if we start at the top, line 31, there's some helpers there that take a unique ID and format it as what we call a UDID, a universal DID. For everybody that's watching this, that's just a DID. And then we can start and say, well, we'll make a cell. Well, to make a cell, what do we need? We need that unique ID, we need the envelope, and we need the envelope seal. We're kind of building the envelope in reverse. Then we need the claims. So if you remember, there was that TA postal address claim structure. It had like the street address and the box number and the slightly different names for the city, state, and country. So we're going to create those claims, and then in the next line, line 37 there, we're going to populate envelope.content by taking the default contexts, the default @ contexts, and the claims and assigning that, and there we've created our envelope content. Then we're going to create the label. That's like that metadata. So we want to have a notarized credential. We want to in terms of a trust level, we want a signed hash signature. It's not going to be encrypted. And then I should have highlighted a little more strongly, a number of the structures, the TSL structures in the trusted level have comments and names, so that you can annotate your credentials just like you would the code, your C# code in your application or your JavaScript code or what have you. So we have comment elements spread around through the TSL. And then in line 41, we see the envelope seal. So we need to create the seal to go on the outside of the envelope. Now I've just kind of dummied in some values. There's the hash thumbprint, there's the signed hash signature, and then there's the notary stamp, which has to do with the verification against the VDR, against the notary service in the VDR. And then there's a couple of comments there. That's just what I would call scaffolding. There's some helper functions that I'm still working on that will actually perform those functions, but it will compute those values and put them into the envelope seal of the cell. So we'll have populated the envelope seal, we'll have populated the envelope. That thing is called PA cell, and in the last line 43, we're going to save the postal address cell called PA cell into local storage, and that's all it is. This is the way that you create named, bound, verifiable credentials in the Trusted Digital Web. So here's the example that I promised you before. I'm going to take the bound credential example for the color palettes, and now I'm going to shade it with those different elements using the structured credential envelope model. So here we see there's the credential envelope. So the credential envelope is everything. The credential content starts with the context and includes the credential subject. It's the data, if you will, whether that be a business document or a driver's license or a birth certificate or a health pass. That's the credential content. The real heart of that business document or that driver's license or that health pass is captured in the claims. And there we can see the ID for this color palette. And then we can see the claims. And the claims, there's a single claim called colors, and the value of the colors claim is an array of 3 things, red, green, and blue. Lastly, we have the packing label, which is that kind of metadata stuff that really doesn't belong anyplace else. And at the bottom, we have the envelope seal, i.e. the proof. The envelope seal is on the outside of the envelope. It's like a wax seal that they used to apply to envelopes and letters back in the day. You'll notice at the very top, there's an ID, and it doesn't sit inside any of those. It only sits inside the credential envelope. It is the ID for the envelope. So for example, if down in the claims and the credential content, you encode purchase order 1234, and you chose to send that purchase order 1234 to Alice, the content and the claims would look exactly the same, but you'd probably put it in its own envelope and send that to Alice. If you wanted to send that same purchase order or invoice to Bob, you could send that same one. It would have the same claim ID down in the bottom, but it would have a different outer envelope. You'd choose a different envelope, or you'd create a new envelope to wrap the credential content and send it off. That's, I guess, one of the big things that the Trusted Digital Web brings to the table in terms of really clarifying the everyday use of verifiable credentials for business documents, and by implication, I think making the model simpler for all users of verifiable credentials. So here we are. We have a verifiable data envelope because it has a seal, because it has a label, because it has content stuffed inside the envelope. And that's pretty much all you need to know about structured credentials. So the highest level of information that can be provided is what I call wisdom. So we've had a awareness or overview section. We've had a section that addressed knowledge and understanding. Let's talk a little bit about wisdom. So wisdom is deeper knowledge and experience gained through experience. And so where we're gathering experience, actual live experience, actual live running code, is through the implementation of the Trusted Digital Web. Again, here's the architecture reference model. I'm not going to detail it in this talk, but it helps us kind of understand and appreciate this continuum of deeper and deeper knowledge that I'll make available in subsequent webcasts. So thank you very much for watching this for the last 30 minutes. I appreciate and value your time. I'll continue to produce more of these tutorials to help you understand the technologies that we're using to create the Trusted Digital Web. Have a great day.